space is rarely in a hurry. From the surface of Earth, the moon hangs in the night sky as a quiet, silver companion. By the spring of 1970, the journey to that pale sphere had begun to seem almost familiar. The world had already watched human beings walk across its dusty surface twice. The first astonishment of the Apollo program had gradually settled into a calmer, more methodical rhythm. Apollo 13 was intended to be the next step, a mission of science, mapping, and careful exploration in a rugged highland region known as Fra Mauro. Fra Mauro was an ancient landscape of ridges and valleys. Much of its surface was believed to contain material thrown outward by the immense impact that formed the Imbrium Basin long ago. Its rocks could offer clues to the moon's distant past, waiting in the airless stillness to be gathered and studied. The crew had prepared for this journey with extraordinary care. Jim Lovell, the commander, had already traveled to the moon aboard Apollo 8. He knew the long crossing and the strange stillness beyond Earth. Alongside him were Fred Hayes, the lunar module pilot, and Ken Mattingly, the command module pilot. Although only Lovell had flown in space before, all three knew their machines, their checklists, and one another's working habits in remarkable detail. They had spent hundreds of hours in simulators, practicing every switch, every maneuver, and every emergency they could imagine. Their movements had become part of a shared rhythm. But spaceflight depends on a delicate balance. Only days before launch, that settled rhythm was disturbed. Charles Duke, a member of the backup crew, contracted rubella and had already exposed the others. Medical tests showed that Ken Mattingly had no immunity. In the cautious world of space exploration, the possibility of a fever during a mission to the moon was a risk NASA could not accept. And so 2 days before launch, the crew changed. Jack Swigert, the backup command module pilot, took Mattingly's place. Swigert was highly trained and knew the command module systems and emergency procedures in exceptional detail. Even so, he now had to join a crew that had practiced together for many months. During the final days, the three men returned to the simulators, repeated the essential procedures, and learned to move together as a new team. The spacecraft itself was a careful union of separate machines. The command and service module, named Odyssey, would carry the crew through most of the journey. It contained their main living space, navigation equipment, electrical systems, oxygen tanks, and the large engine intended to place them into lunar orbit and bring them home. Attached to it was Aquarius, the lunar module. Light and angular, it had been designed for the vacuum of space and for the gentle descent to the moon. It could never return through Earth's atmosphere, but it carried its own oxygen, batteries, navigation systems, and landing engine. Together, Odyssey and Aquarius waited at the top of the Saturn V rocket on Launch Pad 39A. The enormous vehicle stood against the Florida sky, filled with metal fuel, and carefully checked mathematics. Everything appeared ready. The trajectories had been plotted. The machines had been tested. The crew was healthy, focused, and calm. They were about to leave the shelter of Earth's atmosphere and cross nearly 240,000 miles of open space. No one yet knew that Apollo 13 would not be remembered for the rocks of Fra Mauro. Its story would follow a different path, one shaped by patience, cooperation, and the quiet discipline of people solving one problem at a time. On April 11, 1970, the Saturn V rose from Florida in a vast column of flame. At 2:13 in the afternoon Eastern Standard Time, the countdown reached zero. Millions of pounds of thrust pressed against the ground, and the fully fueled rocket began to lift. Inside the capsule, the vibration was powerful. The astronauts were pushed firmly into their couches as the vehicle climbed through the dense lower atmosphere. The journey toward the silence of space began with a few minutes of extraordinary noise. The first stage completed its work and fell away. Then the 5 engines of the second stage ignited. 5.5 minutes after launch, the center engine shut down more than 2 minutes earlier than planned. The rocket had begun to experience severe lengthwise vibrations, an effect engineers called pogo oscillation. Sensors in the engine registered the disturbance and commanded it to stop. For a moment, Apollo 13 was no longer following its planned ascent. But the Saturn V had been designed with generous margins. The remaining 4 engines continued burning for another 34 seconds, and the third stage later burned 9 seconds longer than expected. The adjustments were enough. Apollo 13 entered its parking orbit around Earth, very close to the intended path. The first unexpected difficulty had passed, and the crew continued with the mission. After 1.5 circuits of Earth, the third stage fired again. This burn placed Odyssey and Aquarius on a long trajectory toward the moon. The engines fell silent. Weightlessness took over, and the mission settled into a steady routine. For the next 2 days, the spacecraft coasted through the darkness. The crew checked its systems, navigated by the stars, prepared equipment, and rested whenever the schedule allowed. They also broadcast a television tour of their temporary home, slowly guiding the camera through Odyssey and Aquarius, and showing viewers the ordinary details of life between worlds. By then, however, the public had grown accustomed to the extraordinary achievements of Apollo. Most American television networks did not carry the program live. Inside the spacecraft, Lovell, Swigert, and Hayes continued their work. Earth had become a small blue sphere behind them, while the moon grew gradually larger ahead. The temperatures were stable. The electrical systems were working. The cabin air was clear. It was the uneventful journey they had trained for. But within the service module, among tanks, pipes, heaters, and electrical wiring, A damaged oxygen tank carried a hidden weakness. It waited through the first days of flight for an ordinary command. Almost 56 hours after launch, Apollo 13 was roughly 200,000 miles from Earth. In mission control, the crew received a routine request. The cryogenic oxygen and hydrogen stored in the service module could settle unevenly inside their tanks, making the quantity readings less reliable. Small internal fans were used from time to time to mix the contents. Jack Swigert acknowledged the request and turned on the fans. Less than 2 minutes later, the stillness inside the spacecraft was broken by a heavy bang and a shudder through the hull. Warning lights appeared across the instrument panel. Electrical readings shifted. For several moments, the signals reaching mission control became confused and incomplete. Swigert pressed the microphone button. "Okay, Houston, we've had a problem here." Mission Control asked him to repeat the message. Jim Lovell answered, calm but direct. "Houston, we've had a problem. We've had a main B bus undervolt. Outside, the cabin oxygen tank number 2 had ruptured. The force damaged the neighboring systems and blew a large exterior panel away from the service module. When Lovell looked through a window, he saw something moving past the spacecraft like a pale mist. A stream of gas was escaping into space. It was oxygen. As the supply fell, the fuel cells could no longer continue producing electricity and water. Odyssey, the spacecraft that was meant to carry them into lunar orbit and safely home, was gradually losing the systems that kept it alive. The landing at Fra Mauro was no longer possible. From that moment, every decision served a single purpose: to bring the crew back to Earth. The remaining oxygen in Odyssey had to be preserved, and its batteries would be needed during the final hours of the mission. The command module was therefore powered down. The crew moved through the narrow connecting tunnel into Aquarius. The lunar module had been designed to support 2 astronauts during a short visit to the lunar surface. Now it had to shelter 3 men for the journey around the moon and back toward Earth. The spacecraft could not simply turn around. A lunar mission followed the curves of gravity and momentum. Earlier in the flight, Apollo 13 had left its original free return path so that it could approach Fra Mauro. To come home safely, it first needed to return to a trajectory that would loop around the moon and lead back toward Earth. About 5.5 hours after the accident, the astronauts fired the descent engine of Aquarius for 34 seconds. The burn placed the combined spacecraft back onto a free return path. They continued toward the moon. As Apollo 13 passed behind the lunar far side, Earth disappeared below the horizon and radio contact with Houston ended. For a short time, the crew was entirely alone, moving above the cratered landscape they had traveled so far to reach but would never touch. The spacecraft passed about 156 miles above the lunar surface. Then Earth rose again beyond the moon's edge, and the radio came back to life. 2 hours after their closest approach, the crew performed a second, longer burn with the lunar module's descent engine. This maneuver shortened the return journey and moved the planned landing area from the Indian Ocean to the Pacific, where recovery forces could meet them. Aquarius was no longer preparing to descend to the moon. It was guiding them home. In space, electrical power is closely connected to almost everything else. Power runs the computers, radios, lights, pumps, and heaters. It helps control temperature and keeps the air moving. Aquarius had enough energy for its original mission, but not for several days of supporting 3 people. To make its batteries last, nearly every non-essential system was switched off. Cabin lights were dimmed. Displays and equipment were used only when necessary. The astronauts and the teams on Earth examined every electrical load, preserving one small reserve after another. As the power use fell, so did the temperature. The spacecraft slowly became cold and damp. In some areas, the cabin temperature fell to around 38 degrees Fahrenheit, a little over 3 degrees Celsius. Moisture condensed on windows, walls, and instrument panels. The astronauts wore additional layers where they could. They used equipment carried for the lunar surface to help keep their feet warm. Rest came in short and imperfect stretches, with one crew member usually remaining awake to watch the systems. Water was also limited. The fuel cells in Odyssey had normally produced drinking water while generating electricity, but that supply had disappeared with the oxygen. The crew reduced its consumption to conserve what remained. The cold, the dry air, the cramped conditions, and the constant work gradually took their toll. Fred Hayes became ill with a urinary infection and later developed a fever. Even so, he continued carrying out his duties whenever he was able. There was fatigue, discomfort, and uncertainty, but little wasted motion. The 3 astronauts followed the procedures sent from Earth, checked the numbers, and waited as their small craft moved homeward. Beyond the windows, the moon began to recede. Ahead of them, Earth was still distant, but growing. Another problem developed quietly inside Aquarius. Every breath consumed oxygen and added carbon dioxide to the cabin air. On Earth, that gas disperses through the atmosphere. Inside a sealed spacecraft, it must be removed continuously. Aquarius used round canisters filled with lithium hydroxide to clean the air. But its supply had been intended for 2 people during a much shorter period. With 3 astronauts living inside the module, the canisters approached the limit of their capacity. The carbon dioxide reading climbed toward an unsafe level. Odyssey carried additional filters, but the command module had been built with square canisters. They could not be inserted into the round fittings used by Aquarius. The problem was simple to describe and difficult to solve. A square filter had to be connected to a round opening, far from any workshop or replacement parts. In Houston, engineers gathered the same kinds of objects available aboard the spacecraft. They worked with plastic bags, cardboard from the flight plan, a hose from a spacesuit, and gray duct tape. They assembled a temporary adapter, tested it, adjusted the instructions, and repeated the process until they were confident it would work. Then the procedure was read to the crew over the radio, one step at a time. Inside Aquarius, Lovell and Swigert followed the directions. They folded the cardboard, positioned the plastic, connected the hose, and sealed the joins with tape. The finished device was not elegant, but elegance was unnecessary. It only had to guide the cabin air through the square filter. When the system began to operate, the carbon dioxide level fell from a dangerous reading to a safe one. The air inside Aquarius was breathable again. A few ordinary materials, arranged with care, had solved a problem 200,000 miles from Earth. As Earth grew larger in the windows, attention turned toward the final part of the flight. Aquarius had protected the crew and guided the spacecraft home, but it could not survive re-entry. It had no heat shield. For the descent through Earth's atmosphere, the astronauts would have to return to Odyssey. Odyssey had been kept almost entirely powered down since the accident. Its systems now had to be brought back to life without using more energy than its batteries could provide. On Earth, teams worked in simulators and engineering rooms to develop the necessary procedures. Ken Mattingly, the astronaut removed from the crew shortly before launch, played an important role in testing the command module's restart sequence. He repeated the steps in a simulator, helping to find a method that stayed within the limited power available. Other engineers developed and tested a way to charge 2 of Odyssey's re-entry batteries from the electrical supply in Aquarius. It was an unusual reversal of the normal flow between the two spacecraft, but the hardware could support it. The work belonged to many people: flight controllers, electrical specialists, simulator teams, engineers, and astronauts on the ground. Their separate efforts were gathered into a single sequence for the crew to follow. The instructions were transmitted to Apollo 13 slowly and carefully. In the cold spacecraft, Lovell, Swigert, and Hayes moved through the checklist. Switches were set. Circuits were connected. Displays began to glow. Odyssey was waking again, using only the power needed for navigation separation and the return through the atmosphere. At last, the spacecraft approached Earth. Before re-entry, the crew released the damaged service module. As it drifted away, they saw the full extent of the accident for the first time. A large section of its outer panel was missing, leaving the interior exposed. The sight explained the scattered readings, the loss of oxygen, and the long days inside Aquarius. Then the crew prepared to leave the lunar module. Aquarius had never landed on the moon, but it had completed a different and unexpected mission. It had supplied oxygen, water, electrical power, navigation, and shelter when Odyssey could no longer do so. The astronauts sealed the hatch, checked the connections, and released it. Aquarius moved away from the command module and began its own descent toward the atmosphere. Now only Odyssey remained. The three men were secured inside the small conical capsule, falling toward the blue Pacific. When Odyssey entered the upper atmosphere, the air in front of it compressed and heated. A bright layer of ionized gas formed around the spacecraft, blocking radio signals between the capsule and Earth. Mission Control waited through several minutes of silence. There was nothing more to calculate and no new instruction to send. The trajectory, the heat shield, the batteries, and the parachutes now had to perform as intended. Then the signal returned. Odyssey had passed through the hottest and fastest part of re-entry. High above the ocean, the capsule's parachutes opened. First came the smaller stabilizing chutes, followed by three broad main parachutes, white and orange against the sky. They slowed the darkened capsule and lowered it toward the Pacific. On April 17, 1970, Apollo 13 touched the water less than a mile from the waiting recovery forces. The long journey was over. The mission had not reached Fra Mauro. It had returned no lunar rocks and left no footprints on the moon. Yet it revealed something quieter: the value of preparation, clear thinking, patient cooperation, and thousands of careful decisions made under difficult conditions. The universe is vast, and it does not adjust itself to human plans. But people can observe, calculate, listen, and work together. They can preserve a little power, solve one problem, and then solve the next. And sometimes, that steady rhythm is enough to guide a small spacecraft through the darkness and bring its crew safely home. The cold has passed. The machines are quiet. Rest now. The journey is complete.